In this video, I'm going to talk to you a little bit about the Pythagorean triples and what it means to be a Pythagorean triple. At this point, if you're watching this video, then you have already mastered the Pythagorean theorem. And don't forget, the Pythagorean theorem is a squared plus b squared equals c squared. And that c must be the hypotenuse of the triangle. It must also be the longest side of that triangle. So it's real easy to depict whether something is the hypotenuse or not, because it's going to be the longest side. So in the section 4.4, Pythagorean triples, sides that form a right triangle are called Pythagorean triples as long as they are they follow a couple of rules. All right? In order for a set of sides to be a Pythagorean triple, they have to follow three rules. Rule number one, highlight these. The sum of the two sides of the triangle have to be greater than the third side. So that means if I add up A and B, it has to be bigger than C. So A plus B has to be bigger than C. Okay, what else? It needs to be a right triangle. So that means Pythagorean theorem needs to apply. It means a squared plus b squared must equal c squared. And lastly, they have to be whole numbers, meaning that you are not allowed to have decimals or radicals in them. So no decimals, no radicals. So our integers. So I will have to check all three things. So when we try to find a Pythagorean triple, the first thing I want to check is to make sure that the sides actually do make a triangle. So in number one, I'll check my two smaller sides. 6 plus 8. And is 6 plus 8 bigger than 9? Well, 6 plus 8 is 14, which, yes, 14 is bigger than 9. So that means I have a triangle. Put a little triangle there. I know it's a triangle. Right? Second step is it has to be a right triangle. I'm going to check to see if it's right. I have to do a squared plus b squared equals c squared. So 6 squared plus 8 squared. I'll check and see if it equals 9 squared. That's 36 plus 64 equals 81. 36 plus 64, 6, 7, that's 100. So 100 does not equal 81. So, determine if the sides make up a Pythagorean triple. For this one, the answer is no. Okay. We'll check number 2, 5, 12, and 13. So my two legs are 5 and 12. They're the two smallest sides. So let's first check what happens when I add the legs together. 5 plus 12 has to be bigger than 13. Well, 5 plus 12 is 17, which is bigger than 13, so I do have a triangle. And now I need a right triangle. So in order to be right, it has to pass Pythagorean theorem. So 5 squared plus 12 squared has to equal 13 squared. That's 25 plus 144 has to equal 169. And 25 and 144 is 169, does equal 169. So it is a right triangle, and then the last thing is it has to be whole numbers. Well, I can look at this real quickly and see that 5, 12, and 13 are whole numbers, so my answer is yes. Right, and number 3, I can tell right away question number 3 is a no, because I have decimals. I'm not allowed to have decimals. That is the third condition for a Pythagorean theorem. They have to be whole numbers. And since 2.1 is a decimal, it is not a whole number, so therefore that cannot be a Pythagorean triple. And you can save all the other work. If you add 7.2 and 2.1, you would get something bigger than 7.5. And actually, I think if you square these, it actually comes out all right as well. And what is violated here is the whole number principle. Okay. So the second question says, given 6 and 10, find a third number that will create a Pythagorean triple. So I'm going to have two different answers here. I think two different answers. Let's assume that 6 and 10 are the legs of a triangle. And I'm just going to find the hypotenuse then. So 6 squared plus 10 squared has to equal x squared. So 6 squared is 36 plus 10 squared is 100 equals x squared. 136 equals x squared. So x is going to be the square root of 136. Let me grab a calculator here. If I type in the square root of 136 into my calculator, I get x to be 11.66. So this is an issue. This is a big problem. And it is a problem because this cannot be a Pythagorean triple as we see it in red, because 11.66 is not a whole number. So I have to try this problem a different way. And I want to draw a new right triangle. Between 6 and 10, if one of those two were to be the hypotenuse, it would have to be the 10, because it has to be the longest side. So 6 could not be the hypotenuse ever if one of the legs is 10. So I'll try the Pythagorean theorem again. 6 squared plus x squared equals 10 squared. So 36 plus x squared equals 100. Subtract 36. X squared is 64, and the square root of 64 is 8. So this does give me a Pythagorean triple. So if I know 6 and 10, it has to be a 6, 8, 10 triangle, which is actually part of my favorite triple. My favorite triple is a 3, 4, 5. And if I have a 3, 4, 5, and I double all of those numbers, 3 times 2 is 6, and 4 times 2 is 8, and 5 times 2 is 10. So that is a type of a 3, 4, 5. Okay, the next question says, have you ever wondered where the Pythagorean theorem came from? Although there are many ways to derive the Pythagorean theorem, we will use similarity. The problem is with this one, guys, we have not yet covered similarity. So I am going to go ahead and we are going to skip over this. So if you are watching this video, you can actually go up to the 4.1 things, and you can go in there and see how the Pythagorean theorem is derived and why a squared plus b squared does equal c squared. But since we have not yet dealt with similar triangles, I'm actually going to skip right over top of that one. And it's going to bring me down to the 3 most common Pythagorean triples. My favorite of the 3 triples is the 3, 4, 5. 3, 4, 5 triples are probably my favorite because they're easy to remember because they're sequential numbers. And then there's another one that's called the 5, 12, 13. I used this one a lot actually growing up. I worked construction, and I had a guy once tell me, and why 12? Obviously 12 inches are in a foot. So if I have 5 inches of rise and a foot of run, then if that is going to be a 90-degree angle, the hypotenuse had to be 13. Going back to my 3, 4, 5 triangles. I have 3, 4, 5 triangles, and this is something that I think is really important to understand. It can be a 3, 4, 5 triangle without being the numbers 3, 4, 5. I could actually double each of those numbers. So a 3, 4, 5 is the same as 3 times 2 is 6. 4 times 2 is 8, 5 times 2 is 10. A 6, 8, 10 is still a Pythagorean triple. Right, I could go back to my 3, 4, 5, and I could multiply them all by 3, where 3 times 3 is 9, 4 times 3 is 12, 5 times 3 is 15. That is still a 3, 4, 5 triangle. If I wanted to multiply them by 4, that is a 12, 16, 20. If I wanted to multiply by 5, a 15, 20, 25. And so on and so forth, all the way down to I could do 3 times any number I wanted, 4 times any number I wanted, 5 times any number I wanted. Those are all the same type of triangle, right? They're all 3, 4, 5 triangles. And then same thing I could do with the 5, 12, 13. I could double them and call it a 10, 24, or 26. The other one that's pretty famous, and this one again happens in construction circles, because 24 inches is 2 feet. So if something is 2 feet long and you go up 7 inches, then that diagonal should be 25 inches. So that's another one that works out as well. So as you take a look at common Pythagorean triples, the one that you'll probably remember and probably remember forever is the 3, 4, 5. That is kind of the staple of Pythagorean triples. That's the one that everybody's going to remember. But you also do have 5, 12, 13s, and 7, 24, 25. If you want to see a clever little way to make anything a Pythagorean triple, there is a video, the last video in the Pythagorean triple section in Canvas. The guy's not real easy to understand. His accent's a little tough, but he does show a pretty slick way to make anything into a Pythagorean triple with any 2 numbers, which is pretty cool. So I hope that helps, and if you have any questions, as always, come see me.